Okay, welcome back, guys. Okay, the none of this. Okay, we ended the technical appraisal. We covered all that. Is there anything else you guys wanted to add on technical appraisal?
From my side.
Okay, it's fine. We can just continue then. Okay, the next one, appraisal is now called social appraisal. When it comes to social appraisal, here you will just review in terms of the project design and the processes so that you can identify uh, how the stakeholders can benefit from the project. Or basically you run through the review the entire project in terms of the social perspective. How are the people affected, especially the people in the area where you'll be working on that project? Okay, so it pays attention to the impact of the project on stakeholders, so and the opportunities that they will have for to participate in that project, and also to the contribution of that project to poverty eradication and employment, all those things. Because what people do is they say now, no, let's say now your company, let's say your company is you want to start a company for where you are starting up a mine for, let's say mining, you're mining gold in Namibia. But then let's say even your cleaner is coming from, let's say, China or from abroad, you see. So it's gonna be another issue again. Let's say your engineers, you have engineers here, you have a lot of processes here, you have never have been people with expertise, Namibians, but you are just getting people from abroad. That's another problem again. Because you're supposed to give the opportunities for the local or for the opportunity to the stakeholders to participate in that project or in the development in their community. And in that way, you are contributing to poverty eradication and giving employment also to the people in that region. You also need to understand the people, how those people in that area work, because some of them might not be interested in your project at all. They will actually want to block you. We'll get to understand that also soon. Okay, so in terms of, you need to do a stakeholder analysis, and then you need to understand how can they participate. So you need to know who are the different stakeholders in that project, and and what are their powers and interest. Okay, this you have done already also. You have done an interest and power grid where you are like it's like a quadrant where you have four different quadrants where you can allocate different stakeholders depending on their interests and their powers. I think you have like interest maybe in the, let's say, on the upper axis, on the vertical axis, and on horizontal axis you have like powers. Then you allocate to them to see where they are and the influence they have on your project. So you need to understand how will this project affect now the people in that area. Because sometimes we tend to ignore or not to take this seriously, especially this social appraisal. Because for us engineers, we are just mainly focusing on these technical things, just to get surprised by, let's say, a group of people in the community saying they don't want that project. That project should go. You see, so these are the issues that you will have, and you need to understand now what is the capacity of what is the capacity for them to participate. Do they have the requirements maybe for them to participate in that project? There was an issue now. I took this again from the newspaper now. This one is saying that Himbas still opposed to dam construction. So what was happening is apparently 6 of our Himba chiefs and traditional leaders from a Pupa constituency, they threatened to start a war over the construction of Bayan's hydropower. If that construction of the Bayan's hydropower plant resumes, you see. So these people, it's like these engineers, it's like they did not consult these people in that community. And the people disagree with working on that project. They don't want that project at all, you see. So that's a big issue by itself. Imagine now, these people have started already, they are in the middle of the project. Okay, but because during your identification phase, you've completely ignored or did not consider social appraisal, you will find yourself in this situation. By now, let's say you have spent already your money on already. Let's say you have hired equipment, you have maybe brought all the equipment on site, brought a lot of different people to site. You need to pay them, but the project will not go ahead. You see, I think this project was stopped. You see, that's another problem again. So you need to consider it, but it will depend on where you are working on the project also. If the project is, let's say, within the mine already, then it's fine because it's within your environment already where you are already operating. You have full control over it. But if you are doing it at a completely different area, then it's something else again. Okay, and then when it comes to ecological or environmental appraisal, here you need to understand now, evaluate what is the impact of the project on the quality of air quality, water quality, noise pollution, vegetation, and human life, all that. Okay, this is just in terms of you can remember your environmental engineering, those aspects will come back again here because it has a big effect on your project. It can actually stop it. Even if it was accepted, you can still, even if the financials are making sense, technically everything is good, but in terms of environment, there's a big problem, then there's no way you can go ahead with that project. Okay. And okay, the typical projects that can cause environmental damage include power plants, like that example that was given there, processing plants, this should have been plants, smelters, and phosphate mining. As you guys probably all know, there's an issue already now being placed on phosphate mining. So they've placed a moratorium on phosphate mining already now that you guys might be aware of. You see, so if you could have considered this in the initial phase of the project, before you even start working on the project, you could have done some what we call the project level environmental assessment, which is also referred to the environmental impact assessment. So you can assess now the impact of that project on the environment and everything there. You see, by the time you start proposing to start this project, you would have concrete evidence on it that no, maybe phosphate mining will not harm the environment. This is what we found, like that. You see, but if you do not do it, it becomes very difficult. But you guys have done this environmental impact assessment, isn't it?
Yes, sir. Impact assessment.
Yeah, so it links up with that again. So you cannot just ignore it. But which means now in your project team, maybe you need to have some experts in the environment so that you as a project manager now, you need to make sure that those guys under the environmental side, they do those things. Because if they don't do it, then it's going to be another problem again. The environmental guys do those environmental aspects. Then you have maybe a metallurgist and maybe electrical, mechanical guys. They will focus uh, on the technical aspects. They can also do the financials, all that, you see. That's why you as a project manager, you are not only doing these technical things alone, you need to oversee all these things because at the end of the day, you are the one accountable for everything.
Sir?
Yes.
So now, like the environmental impact assessment, is it done way before before operation is done on site, or is it sort of in the form of, say, for instance, paperwork now, how you plan on operating or running your company in such a way that you don't affect the quality of air, water, and noise and all that? Is it something that you have to do before you even implement the project itself, or does it fall after you have started the project?
I think you can do some preliminary tests or some experiments before just to verify. Because let's say now you want approval from they call it environmental clearance or what? Yeah, I think if it's environmental clearance, let's say from the Ministry of those guys in the environment side, they might ask you such questions and you cannot answer them. If they ask you what will be the impact of your project on the environment, you need to have full backup information on that. You have done a complete study on it. So like that, it will make things easier. Let's say now if you do not do it at all, then those guys will also be start doubting you that this guy is not sure about the things he's doing also.
Okay.
But again, when you are executing, you also need to, it's like you also need to review and monitor the impact on the environment also, just to make sure things are going accordingly. So you just don't
Yeah.
do it at the beginning and then you leave it. It's continuous, depending on the project you're working with.
Yeah.
Mm. Okay, now financial appraisal. Okay, so here now you need to ask yourself now, should we really invest in this project or not? This is in terms of now financials now, the money talks. So financials, money is
But
limited. You don't have all the money on this planet, so you need to make sure you invest it in the right spot, in the right project. So the question is that project financially viable? Okay, and if it's financially and will it meet the expected returns? Will it even will it reach its break-even point? What are the expected cash flows for the project? You see, investors would want to know that. Because remember, at the end of the day, they are putting in their money, they are putting in millions of dollars in that project, but they must expect to get a return from that project. So the options that you have when it comes to financial appraisal are things like payback period, net present value, internal rate of return, profitability index, sensitivity analysis. So these are all the tests that you will do. I'm quite sure you guys have done these things probably a lot, isn't it? You did it in mineral economics, isn't it?
um, yes, sir.
Okay. Okay, we can run through them quickly. The first one is payback period. This is, as the name suggests, payback period. Okay, is the amount of time basically by which you will be able, by which the project will be able to cover the initial investments or the initial investments that was done into the project. So the question is that the question that the investors will ask you is, after how long will we get back our money that we've invested in the project? Okay, after how long will it be? If it's too long, then it means it might be a challenge to get that project financed. But it depends also on the firm itself, on what do they prefer. So you usually calculate it by dividing project cost or the initial investment divided by the annual cash flows. Then once you divide that, you get your answer in terms of years. Just a simple calculation. Okay, oh, like I said, okay, the advantage for this method is that it's simple. If someone asks you, let's say you are a manager, and then someone asks you in the meeting, how long do you think, what will be the payback period? You can simply estimate it. It's that simple. But the disadvantage is that it does not consider the time after the payback period. Okay, because a lot of things can happen there also. Then maybe the project will cover up the amount that was invested in. But then after that, that operation is gonna start again, maybe running at loss, again subtracting from the initial investment. I mean, the initial amount gained, and most importantly, it ignores the time value of money. That's another concept for itself. Again, it's you don't want to. It's like the tricky part is that you are not sure now, because remember the time value when it comes to time value of money, the money having the money now is better than having it later, because the value of the money depending on, because you can use it right now. So this concept is that disadvantage. And in terms of accepting or rejecting it, normally the company sets, okay, it sets an acceptance criterion for this payback period. They can say no. If a project is more than 5 years, put it on hold for now. Now we only want projects that has a payback period of 3 months, 3 years and less. Maybe they can tell you something like that. And most importantly, the lower payback period, the better. So if you're comparing, let's say, three projects, uh, you can compare in terms of their payback periods. the one that will give you the lowest, where you can actually get a return on your investment quickly, is the best option that you might opt for. But it depends also. Remember now, it did not consider the amount of money invested in that project also, because this thing is just like it's a ratio. It's basically the time. It's only considering time. But let's say now one project you have invested 1 million, the other project, okay, let's say you have invested 1 million in it, but then it has a payback period of let's say 5 years, while the other project you have invested in 10,000, but then it has a payback period of, let's say, 1 year. You see, in the long run, the other project, if you were to succeed with it, in the long run, you will win more. You see, so it doesn't consider such things also. Yeah, a typical example is this one. Okay, here they have made an investment of 150,000. Okay, so each year the cash inflows is 32,000 for all 5 years. So basically, what you do is you take that 150, then you divide it by the amount as time goes on. Now you add them up. Let's say two of them, then you divide it and see how long will it take. No, it's still not going in like that. How long will these inflows reach this 150,000? If you had to add the 32,000 plus 32,000 plus 32,000 plus 32,000 like that, after how many of them will you reach 150,000? That will become like your payback period. So like this one, it will take about 4.69 years. So basically, if you take that 150, then you divide it by uh, by 32,000, because it's constant for all the years, then you should get that 4.69 years. Okay. So the payback period should be somewhere between 4 and 5 years. This is quite simple. I'm sure you guys should be able to understand that. And NPV, the other one is NPV. Okay, the NPV, it's basically a sum of all the present values for all the inflows and also the outflows. It's as simple as that. So all your inflows, you convert them into their present values. Once you get them for both inflows and outflows, then you sum them up together. That should give you your NPV, your net present value. It's net because you're adding the inflows and outflows. And remember again, your outflows will have a negative because it's outgoing. Remember? So what is that net now? That is the difference between inflows and outflows, which are now converting to present value. What will that amount be? That net. Okay, and this is the formula summation of the flows, the inputs per year now, divided by the 1 plus, this is the interest rate that you have down here, to the power t. That's the time, the amount of time that you've invested in. Okay, the advantage of this NPV is that it considers time value of money. Okay, and the disadvantage is that it does not really consider the gain or loss of executing the project. It's like it's mainly just focusing on on getting the net, the net present value itself. It does not necessarily focus on the gains and losses during when you are executing the actual project itself, during that period of executing. And when it comes to the criteria for accepting or rejecting it, basically what they say is if the NPV is more than 0, it means now the project will add value to the firm. If it's more than 0, it basically means your inflows become more than your outflows. So you it's generating more money coming into the firm. So that project it's bringing in more money. So like that, it's a good project. So you can actually opt for that project. If it's less than 0, then it's removing. Yes.
What do you mean when you say it does not consider the gain or losses of the execution of the project?
I think they were referring to, let's say, losses and gains when you are executing the project. The cost that you are incurring during project's execution, in terms of gain and losses there. It's not really considering that because it's just looking at the lump sum inflows and outflows.
And well, can that be a disadvantage? I mean,
Yeah, I think it's just in terms of it's not revealing all the information that you will need. Because all I'm gonna give you is, let's say, this final value here, this 57174. That's all I'm gonna give you. But you will not see the transactions within the project itself. Let's say now if I have overspent somewhere during within the milestones of the project, it does not show you that. It only checks on the net. On the net, it's a net because you are subtracting the two values, the inflows and outflows.
uh,
Yeah, and if the NPV is equal to 0, so it's like it's breaking even. Okay, this is just a small. This picture is from, I think they did it in Excel. I think you guys will be required to do something similar where you will be doing these IRRs and NPVs, especially for your design project. So you're gonna have to put these formulas in Excel and do that. I think Excel can easily do that for you. So, is that what you're working on, Ju? Is Ju with
excuse
us?
me, sir?
You are the one working on coming up with this spreadsheet, né? Excel spreadsheet where you are doing your financial evaluation.
Yes, I do need it, sir. I need to do something similar. So,
Yes. Because I remember even doing something similar also for my design project. Okay, so this is now a net present value. Now here we are comparing now for net present value for three projects, project A, B, and C. Okay, you can see here you have your discount rate 10%, this one is 11. You see these things are changing, the discount rate is changing. In the period, how long it will be, and the initial cash flow is this much, 125,000, 150,000, 170,000, like that. Then when you check now your project NPV, it's like this for this one is like 137. If you compare it with the initial cash inflow now, if you have to compare it, you can see that it's actually we have actually put in it's actually lower, like for project C, it's actually lower than the initial cash inflow. But nonetheless, you are still making money there. You may still be making money, but then other projects are making more. Let's say like in terms of the NPV for project B here, you can see it's 168. It's like it has exceeded the initial investment by 18,000, almost 19,000. It's like 12% more. So which means this project B, it's actually it might be wise to actually opt for project B maybe, or maybe project C. I mean project A, then compared to project C. So you're gonna compare different projects in that way. Okay, and then the next one is internal rate of return. Basically, internal rate of return is basically a rate, or what you call a discount rate. It is a discount rate at which your NPV is equal to 0, which means your present value inflows and present value outflows should be equivalent, so that when you add them together, they give you 0. Remember, the outflows are negative because of the money going out. So normally, what we normally do is this equation is the same equation you use for NPV, but what you do not know now is this rate, this discount rate. So if you plot this on the graph, you have a discount rate on the horizontal axis, and maybe the amount, the cash flows on the vertical axis. So where that graph cuts the horizontal axis, that's where your NPV is equal to 0. Now that's now the internal rate of return, that discount rate. So the advantage of this is that it considers the time value of money, and it's more of an indicator of efficiency because it's in percentage wise. Okay? But then the disadvantage is that it does not, you cannot use it to compare different projects of different durations, and even projects with different cost inputs. If your cost inputs are different, it might not do a good comparison there. And in terms of accepting or rejecting it, that project, the project is usually considered acceptable if the internal rate of return is more than the established minimum. So basically, the company will put up a number like, let's say, any project less than, let's say, 30, having a IRR less than 30%, will not accept it. They can do something like that. But nonetheless, if you only have two projects that you're comparing, the project with the higher IRR, it means you have more room for change or for anything, any risk that might happen. So the higher the IRR, the better. Okay, so this is the typical graph that I was talking about. You also have your NPV or your cash flows here, your summation of the inflows and outflows, their present values, the vertical axis, and then on the horizontal axis, here you have your discount rate. You see that this project in yellow, you can see here, it's cutting off somewhere, maybe let's say 36, 37, somewhere there, percent, while this project in with dark spots cutting at 20% discount rate. So, which means now the project with the yellow line is actually more acceptable than the other one. Yes. What do you think?
Mm-hmm. I think, yeah, it is. I mean, regardless of the NPV being high, I think the one in boxes is better, saying that the IRR is 40%.
Oh,
So hence, it's likely that the payback period. Sir,
yes.
Will I be right if I say it's likely that the payback period for the one in yellow would be shorter than the one in black?
Yeah, I think you can maybe
now considering that if I'm not mistaken, IRR sort of gives us that how, like you said, an indicator for efficiency, how the company would be doing. I mean, in terms of recouping your investment, if I can put it that way. Like, say, for instance, can I say 40% will probably, or 40% of the investment would be recouped, for instance, maybe in what, say, in a year or two? Will I be right if I have that kind of thinking?
Yeah, I think maybe it's best to, if it's me, I would best do it when you have done some calculations, because again, remember the payback period. It's again the payback period itself somehow does not consider even the time value of money, but this guy considers it. This is more of a rate. And again, it depends. When it comes to payback period, it is considered also the factor. I mean, the amount paid. Yeah, but maybe I'm not sure.
Okay.
I'm not sure. I'm not sure. What do you think? Who is the other one?
Um, either way,
Yes,
the project on the one in yellow still is the best project to make
Yes, yes.
investment in.
But are you able to relate
Yeah.
all this, let's say IRR, NPVs, all this, deduce that if the NPV is high, if the IRR is high, then it's most likely that the payback period will be short also.
Yeah. Like when the IRR is high, then it's likely that the payback period will be short. That I'm quite familiar with.
Maybe you can look at it in terms of the formula, perhaps you can conclude it maybe from there, that by judging on the formula, maybe we need to calculate looking at this formula maybe and see how time, as you change the rate here, how is time affected there, then maybe you can conclude on that.
Mm-hmm.
Because remember, if this IR, if this rate is increasing, it means the value that we have here at the bottom is increasing. Okay, I think first you just need to make T the subject of the formula here, and then you will see how I will respond to that by looking maybe at the
Oh,
equation
yeah.
and make it the subject. Then you can make your good conclusion, I think.
Mm-hmm.
Because I think it might be tricky to conclude too early, but it's possible. It's actually possible. It's most likely, but we just need to prove it.
All right. Yeah.
Okay, the other one is profitability index. Okay, profitability index. This is basically just a ratio of discounted cash inflows divided by cash outflows. It's as simple as that. Inflows divided by outflows. So the advantage is that it considers the time value of money. That's why they say it's discounted, and it's a relative. It's a relative to the project. So in terms of the let's say the amount of money you've put in, it's taken into account there. And the disadvantage is that it considers to fail, or not it considers to fail, it fails to consider the absolute values of the contribution of the project. Let's say now, in terms of, let's say, monetary value, it does not give you the monetary value. Let's say, like, if you remember, NPV is an exact amount. It's giving you certain, let's say, millions of Namibian dollars, like that. It's a value itself. So this one does not give you that. It just gives you a ratio. And the other disadvantage is that it's just a relative indication. It can be a little bit tricky there because it might not fully give you a good indication of the entire project of if you can really conclude that it's a good project or not. So maybe you will need to use it with other techniques maybe. And when it comes to acceptance or rejection, all they are saying is the higher, if the profitability index is more than one, it means the project is good. You can easily get a return on your input, on your investment. Okay, and then the next one is the sensitivity analysis. So with sensitivity analysis, all you are doing is you are assessing, or you are analyzing how the how the how the project will be affected by a number of variables. Let's say now, if let's say the price, let's say like on this example, what you see here, this is in terms of now oil price, capex, opex. If all these things start changing, how will it affect the NPV of your project? So you need to play around with them, change all of them. When you're changing them, sometimes you might even want to hold others constant. Then you see how the NPV will behave. So you just want to see how sensitive is your projects in terms of NPV. Because in real life, in industry, things are changing. So you need to consider that those changes. Okay, so this sensitivity analysis is also referred to as what if analysis. So you're asking yourself, what if the oil price increases? What if it drops? What if it like that for all different variables? Okay, and is this clear so far?
Now, sir,
Yes, sir.
in terms of acceptance or getting what let's say it's a good result that conducted, what question then say we can still agree that we'll get on investing project after conducting the sensitivity analysis.
Do you mean what?
Like I'm trying to understand also.
You're saying,
Like the same way we establish understand, say for instance, index like that in one, then we are guaranteed, hence we are likely to give to get a green light for the project. Now,
like
in terms
here,
of sensitivity analysis,
okay. Or you are saying like here for profitability index, if it's greater than one, then it's most likely that we can accept the project.
I was just
So how do
Yeah.
we accept here when it comes to sensitivity analysis? Oh, I'm not understanding your.
No, no. When it comes to sensitivity analysis, obviously now say there have been changes in the price of our product or in terms of capex or in OPEX. Now, in to affect NPV. Now, how or to sort of say, okay, they have been changed, but still we can proceed further with the execution of the project. Do you get my question?
Okay, how do you conclude now based on this analysis? Is that what you are referring?
Like, say, for instance, for these specific examples, I'm seeing these lines and I'm still not quite understanding what it's actually all about. We have lines here for OPEX, CAPEX, and oil price. At which point now do we say, okay, if there is this amount of change, it will give us an NPV of this, and hence, at this point, we can still give a go ahead the project. So, is it where the three lines intersect, or what conclusion can I make from this graph?
I think it will depend on the firm. Let's say now the firm can decide and say, no, the NPV that we want, it should be let's say 50,000 here. Okay, let's say 50,000 million here. So you can see that all these points down below that 50,000, all those changes, the project can actually handle them. But if it comes here where there is let's say where there's a capex of this much, oh, how much is this? 160. This is 138. When the capex changes to 138 here, then it becomes a problem.
Mm-hmm.
So you have to look into all the variables and see now which ones are within the criteria which is set by the company.
Okay. And I also notice on the x-axis we have percentage. I want to understand what percentage is this for.
They did not give an indication here. Probably, I'm not sure what that is. I'm not sure in terms of the percentage. No, they did not give an indication of what percentage this is. I'll probably have to look where I got this. They did
Okay.
not give an indication of the x-axis. But the main point is that if you look at all these variables, how they are changing, and then you compare now how is it affecting your NPV. If you look at your NPV on this side, then they are plotted there. Then you see if your NPV is at a specific, let's say your criteria is, let's say it should not go below 100 million, then you can actually tell that from here, from the data, what are the conditions. You can see that all this, let's say if they say the NPV should not be lower than, let's say 150, it should not be more than 150 million. Then it means all this you can actually, all these points you can actually operate within them for your project, and it will still be successful. Is that fine so far?
So, quickly want to ask a question.
Wait,
What if they say that we should operate at, like, say for example, 60 US dollars
oh, Islam.
NPV? Then yeah,
The
then
time though, it's about to
where
disconnect.
where where will where do your points have to
Marvin,
be now?
maybe Marvin,
We only have 1 minute.
Yeah, yeah, we can
Marvin.
yeah.
I'm saying it's about to disconnect. Maybe you can just ask the question in the section
Next
that you will rejoin after.
yeah,
Okay, but nonetheless, this was the end.
yeah.
Yes.
Okay, so
Okay, but there can always be other examples like the one given by Nobet. We can always check that one also and analyze it.
yeah.
It depends on how you put
Mm,
the spreadsheets and the data.
mm,
Yes.
mm.